Hi everyone. This video may be better if I show you on a whiteboard as opposed to just do it on IXL. This is for IXL skill J12. It's called using the discriminant. Now we use the discriminant in order to tell how many solutions there are in a quadratic function. So whenever you solve for the roots of a quadratic, you want to use either factoring or the quadratic formula. The quadratic formula is that complex one that we learned, remember? Sing it with me if you remember it. X equals negative b plus or minus square root b squared minus 4ac all over 2a. So when we use the quadratic formula, we're using this to find the roots of the function. Now the discriminant is part of this formula. The discriminant is this part. The part that's underneath the square root. So if we do this, then we can actually figure out how many real versus complex roots are there. Now, it's a quadratic function, so we know that there's two roots because it's to the second degree. But what we really want to know is, are they two real roots? Is there only one real root? Or are there actually two complex roots or two non-real roots? So let's go ahead and let's solve a few problems. We're going to go through these four. All right, and we're going to use them in order to find the discriminant and see what that means. All right. So the first problem that we're going to use is 7u squared plus 6u minus 6 equals 0. So your first step is to identify your a value, your b value, and your c value. Your a value is 7 because it's the coefficient of the squared variable. Your b value is 6 because it's the coefficient of the variable to the first degree. And your constant, your c, equals negative 6. One of the biggest mistakes people make here is not including the negative sign if it's in front of the coefficient or the constant. So make sure that you use the sign in front of it. Since this one doesn't have a sign, it's just positive 7. So let's plug it into b squared minus 4ac. B squared would be 6 squared. Let me write it out. B squared minus 4ac. And depending on our answer, we'll see whether there's one real root, two real roots, or no real roots. So b is 6. So let's do 6 squared. Sorry, I'll keep this in red. Minus 4ac. A is 7. C is negative 6. So b squared, 6 squared would be 36. Minus, let's see, negative 4 and negative 6. When we multiply those, we get positive 24. And positive 24 times 7. Feel free to use a calculator to do this, but 7 times 4 is 28, and 20 times 7 is 140, so 140 and 28 would be 168. So this should be 36 plus 168, which is 198 plus 6 would be 204. So the discriminant is 204. Now what this tells us, imagine if we plugged in 204 here, right? So if we add negative b plus or minus the square root of 204 over 2a, no matter what these other values were, since this is a positive square root, it's going to have two answers. It's going to have the positive version and the negative version. So when this number is positive, when the discriminant is positive, it tells us that it has two real solutions. So this has two real solutions because the discriminant is positive. So no matter what the number is, if you get a positive value, then you know that it has two real solutions. Let's look at a couple other examples. The next one we're going to look at is 3s squared plus 3s equals 0. Now in this one you want to be careful because the a term is right here, positive 3. The b term's right here, positive 3. But what's the c term? Since there is none, c equals 0. Go ahead and plug these in. Find the discriminant. B squared minus 4ac. Let's see, b is 3. A is 3. And c is 0. So first we do exponent. 3 squared would be 9. Then we go ahead and multiply. Negative 4 times positive 3 would be negative 12 times 0. Oh, anything times 0 becomes 0. So this would just be 9 minus 0, which is equal to 9. Since this is positive, that means that there's two real solutions. Let's try two more examples. Six p squared plus 4 equals 0. All right, what's our a value? What's in front of the square? 6. What's our b value? What's in front of the p? Oh, there is none. So b equals 0. And our c value is the constant. Let's go ahead and plug this in. B squared minus 4ac. When we plug this into the discriminant, we'll have 0 squared, because b is 0, minus 4, let's see, a is 6, and c is 4. So 0 squared is 0, minus 6 times 4, which is 24, times 4. Let's see, 20 times 4 is 80, 4 times 4 is 16, so 80 plus 16 would be negative 96. 0 minus 96 is negative 96. Now you see how we got a negative answer here? Well, let's see what would happen if we plugged in that negative 96. So if we plugged in negative 96 here, we get negative b plus or minus the square root of negative 96 over 2a. We can't take the square root of a negative number and get a real number. When we take the square root of a negative number, we would write it as something I meaning imaginary. So because this is an imaginary number, it's a negative square root, there are no real solutions. There are two complex solutions. So whenever you get a negative value for the discriminant, there's no real solutions, but rather two complex solutions. Let's do one last example that's a little bit different. All right, in this example, we're going to have to do something before we can solve. If you'll notice in all the other examples, the equation was set equal to 0. Oh, sorry, you can't see that. There you go. This one said equal to -4. So the first thing we have to do is actually get it equal to 0 first. So if we add 4 to both sides, then this will be equal to 0. 3x squared plus 4 equals 0. Now we can identify a, b, and c. So our a value is positive 3. Our b value, there's no x, so it's 0. And our c value is positive 4. Now that we've identified those, let's go ahead and plug it into the discriminant. B squared minus 4ac. Well, b is 0, we said. So 0 squared minus 4. A is 3 times 3. C is 4 times 4. And let's see what we get. 0 squared is 0. Negative 4 times 3 is negative 12. Times 4 would be negative 48. Since you get a negative number here, this means that there's two complex or non-real solutions. Now there's one example that we didn't get. Oops. And that example is what would happen if you had something that actually only had, if you got a 0 for the discriminant. So let's come up with an example where 0 would be the answer. All right, I think this will work. Let's check. So let's go ahead and solve this one. Our a value is 1 because there's no number in front of the square. Our b value is negative 6. And our c value is positive 9. Let's plug it in for our discriminant. B squared minus 4ac. B is negative 6. Squared minus 4. A is 1. And c is 9. Negative 6 squared would be a negative times a negative, which would be positive 36. Minus 4 times 1 is 4, times 9 is 36. Look, we got 0. Now when you get a 0, that means that you would be having something like this. Negative b plus or minus the square root of 0 over 2a. So that's an a. So let's think about this. Whenever you add the square root of 0, well, the square root of 0 is just 0. So what's going to end up happening is you're going to add or subtract nothing, which means you're not really adding or subtracting, right? So you're only going to have one answer left. That plus or minus doesn't really add or subtract anything. So there's really just one real answer. So that's why when you get 0 for the discriminant, there's only one real solution. And if you graphed this, it would actually look something like this. And you would see that repeated root, or that double root right here. And in this case, it would be at positive 3. All right, I hope that this was helpful, and I hope that you're able to use the discriminant to be able to tell quickly how to find how many real and how many complex solutions there are in the quadratic function.